Okay, so the second 9 weeks, first video, is now on reasonable domain and range and using function notation. Now, we've been going over domain and range, and you guys had that wonderful intersession video, which I hope you loved. Now we're going to be talking about what reasonable domain and range is and function notation. Well, we've already been doing some of this function notation. Okay, so here it gives us a function. W of x is equal to 250 times x. It represents the number of words, W of x, you can read in x minutes. How many words can you read in 6 minutes? So, here we're just evaluating. And remember when I told you guys that you hear that word evaluating, means you're going to plug in. Well, here it's actually telling you how many words can you read in 6 minutes. So if x is minutes, then we're just going to plug in, right? We're going to plug in. Oh, get my pen. We're going to plug in W of x is equal to 250 times 6. So that's all we're doing. We're plugging in. What's 250 times 6? So that's 0, 0, 12, 13, that's 1,500, I think. Double check me. So in 6 minutes, you should be able to read 1,500 words. That's all this is. Let's look at the next one. Okay, so now it's giving us the domain of g of x is equal to 4x minus 12 is this list of numbers. What is the range? So if these are the input values, that's what domain is. Remember, domain is input values. Then it's asking for the output. So we're just going to do. We're going to input the numbers into this function. So we have 4 minus 12. The first number is asking us to put it as 1. And then we're going to evaluate the function of 4 times 1 is 4 minus 12. Is equal to negative 8. Okay? Then we're going to do that with the next number. The next number is 3 times 3 minus 12 is equal to, so 4 times 3 is 12 minus 12 is equal to 0. So then we have negative 8 so far as an output and 0 so far as an output. So now we're going to do the next number, 5. 4 times 5 minus 12 is equal to, well, 4 times 5 is 20, minus 12 is equal to 8. So there is our third output value. And then we're going to do the last one, 7. So then we're going to input 4 times 7 minus 12 is equal to, well, 4 times 7 is 28. 28 minus 12 is 16. So right there, negative 8, 0, 8, and 16. So our range is negative 8, 0, 8, 16. Don't forget your brackets, your braces. Don't forget to put them in least to greatest order. So now, the range of h of x is, here's your function. Now it's giving you the output. Be careful here. It's telling you the range. These are the output values. These are the range values. So instead of plugging them in for x, now I'm going to plug them in right here for h of x. So the first one I'm going to have negative 5 is equal to 3x plus 1. Negative 5 I'm going to input here. It's my range. It's my output. It's asking me for my domain, my input. Okay? So all I'm going to do here is I'm going to do exactly what it tells me to do. And now I'm going to solve this. So I'm going to subtract 1. Negative 5 and a negative 1 is a negative 6 is equal to 3x. Divide by 3. Divide by 3. A negative divided by a positive is equal to a negative, right? These cancel. 6 divided by 3 is 2. So my first domain, my first input value is negative 2. Then we're going to do it for the next value. I have negative 2. So now I'm going to write negative 2 is equal to 3x plus 1. I solve for x. A negative 2 and a negative 1 is a negative 3 is equal to 3x. I divide by 3, divide by 3. So x is equal to a negative divided by a positive is a negative. 3 divided by 3 is 1. There is my second domain value. So now you guys will have to give me the answers for the final 3. All right, for what value of x is the value f of x 4x minus 2 equal to 18? Now, this one is just reworded a little bit. It's telling you what value of x. What value of x? So I know I'm going to have to find x. What value of x is equal to 18? So I'm going to put 18 equals 4x minus 2, and I'm just going to solve for x. Add the 2, 20 is equal to 4x, divide by 4, divide by 4. So 5 is equal to x. So what value of x? The value is 5. 5 will make this true if it's equal to 18. All right, so now we're going to get into some reasonable domain and range. Come on. Sorry guys, technical difficulty. So here we have a whole sentence. You have 3 quarts of paint, and you want to paint the trim in your house. 1 quart of paint covers 100 square feet, okay? And it's giving us a nice function. So it represents the area in square feet that how many quarts of paint we have can cover. So what is the reasonable domain and range for this function? Okay, well, we have a formula. We have the area is equal to 100 times quart, right? Times how many quarts we have. Well, we have 3 quarts of paint. So we can actually paint 0, right? We can use 0 quarts of paint. We can use 1 quart of paint. We can use 2 quarts of paint. And we can use 3 quarts of paint, right? This could be our input values. So I'll make a table. These can be our x values. These can be our y values. In this case, it's Q. Okay? And this is A for area. So, now, let's look at our table. Well, if I use 0 quarts, obviously I'm not going to paint anything, so I'm not going to paint any area, right? So that's 0, 0. Now, if I use 1 quart of paint, and if 1 quart of paint covers 100 feet, I plug in 1 right there. 1 times 100, well, 100 square feet, right? Now, 2. If I use 2 quarts of paint, well, I just plug it in. 100, I'm going to use 2 quarts of paint. That's equal to my area.
You have a phone call.
2 times 100 is 200.
1, 4, 2,
So then again, we're
5,
going to do the 3.
9, 2, 3, 6.
So we're going to plug in 100 times
9.
3 quarts of paint is equal to the total area that I can cover. And that's 300. Okay? So with 1 quart of paint, I can cover 100 square feet. 2 quarts of paint, I can cover 200 square feet. And 3 quarts of paint, I can cover 300 square feet. So, what is a reasonable domain and range? Okay, well, my domain. A reasonable domain can be anywhere from 0 to 3, correct? Because I don't have to just use 1 quart. I can use half a quart of paint. I can use 0.33 quarts of paint. I can use 0.01 quart of paint if I want to be picky, right? So my domain is going to be, x can be anywhere between 0 and 3, including, because I can do 0 and I can include 3, right? So now let's look at my range. Let's do purple. My range. Now, my range is my y, right, is going to be anywhere between 0 and 300 square feet. I can paint 244 square feet. I can paint 102 square feet. I can paint 100.09 square feet. So, reasonable, I'm going to do my lowest number to my highest number, and of course, boo-boo, it's a 0. It's supposed to be a 0. It's supposed to to be a 0, right? And here, for X and Y, technically, I should be using Q for quarts and A for area. So there's my reasonable domain and range right here. Okay, this is how you find out what your reasonable domain and range is. Let's go to the next one. You have invited 3 friends. 3. To go to the movies. You know at least one will join you, but you are unsure about the others. Ticket cost $11 each, and the function CT, that's the total cost, represents the tickets, right? What is a reasonable domain and range? Well, if they're $11 each, that represents my total cost, right? And it's using a T, so don't get scared. Okay, it's just a T for tickets. Okay, it tells me right here. Remember I told you this is a function? This C is going to tell you it's a function, and then the following variable inside the parentheses is what you're going to use in the function. So I'm going to use T for tickets and C for total cost. Okay, so I'm going to do the same thing. I'm going to make my table. T for how many tickets and C for my cost. Okay, so now, of course, I'm going to the movies, right? And I've invited 3 friends to go to the movies. Okay, so if nobody goes to the movies, that can be a 0, right? One person can go to the movies, that's just me. Myself and one of my friends can go to the movies. Myself and 2 of my friends can go to the movies. Myself and 3 of my friends can go to the movies. So all 4 of us. This is if all 4 of us go to the movies, right? Okay. So now let's do this. Now what we're going to do here is this is our domain. Okay, this is our domain. Now all we're going to do is we're going to plug this in here to figure out what our total cost will be. Well, if nobody goes to the movies, then I'm not paying anything out of my pocket, and we're good to go. Now, if it's just me going to the movies, if I plug in the 1 right here, I'm going to have 11 times 1, right? That's just going to cost me $11. Okay? Well, if me and at least one friend shows up, we both go to the movies, right? 2 times 11, that's $22. And then if 3 times 11, 33. 4 times 11, 44. Okay, so this is what a table might look like. Okay, now let's read what the question says. Now I did a table from 0, okay, but the question is actually asking you, you know at least one friend will join me. So I know at least 2 people, right? At least 2 people are going to the movies. Me and at least one friend, we're not sure about the other 2. So this is the part of the table that I am going to pay attention to. So now, my domain. Now this is different. My domain is now not x's between 2 and 4 because these are people, right? This is discrete. Remember, this is discrete. The paint is continuous. This is discrete. So this is just a list of points. So my domain, my reasonable domain will be 2, 3, and 4. That's going to be my reasonable domain. Okay? Now let's look at my range. My reasonable range is going to be 22, 33, and 44. 22, 33, and 44. And close my brackets. And remember, you can't buy 1.5 tickets. You can't have 2.5 people. That's how you know this is discrete. This is how you know it's just a list of points. Okay? When we look back at the paint, we can use anywhere between 0 and 1 gallons. It's continuous, right? It's continuous. This would be a continuous graph. That's why we have continuous domain between 2 numbers and a range between 2 numbers. Okay, so be very careful. All right, a car can travel 32 miles for each gallon. Uh-oh, 32 miles each. There's a power word. The function, we have a function, represents the distance that a car can travel with X gallons of gasoline. So the car's fuel tank holds 17 gallons. Okay, again, we can make our table, right? And then we have our function. Sorry guys, I keep getting technical difficulties here. I have to come back to the computer. Okay, oh, see what I mean? Okay, let's see if this is going to work now. There we go. Okay, so then we have our function 32x. All right, our fuel tank can hold 17 gallons of gas. Okay, so a car can travel 32 miles for each gallon of gas. Okay, the function represents the distance in miles that the car can travel, blah, 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 blah. And the car's fuel tank holds only 17 gallons of gas here. Okay, so what would be our domain? Well, our x value, our domain, is the miles, correct? Is the miles. So I can travel 32 miles on 1 gallon of gas. Okay? So, if I can travel 1 mile, oh my goodness, 32 miles for 1 gallon of gas, right? How many miles can I travel, right? So here's my 1 gallon, 2, 3, all the way up to 17 gallons of gas, right? So this is my gallons of gas, and that is x. And then d of x is my distance, that's my total miles, so 32. And then I just keep plugging it in. 2 times 32, 64. 3 times 32, 96. And I keep going all the way down to 17. Now, my first question, would this be continuous or discrete? My second question is, what would be your reasonable domain? That's my second question. And then my third question, what would be your reasonable range? There you go, guys.